Hey everyone, welcome to our webinar on AI Ops and Cloud Native Observability. We have Pradeep and Vijay with us. They have more than 20 years of experience in engineering services and R&D innovation related stuff. So it's going to be a webinar from very experienced folks. So uh, all yours guys, you can introduce yourself and then kick things off.
All right. So, can we get started? So, good morning, good evening, and good afternoon to everyone. So, here we started with this AI Ops for Cloud Native Observability. So, the agenda for this meeting would be first we will go through this definition of what is observability, and then we will look at what is the industry problems, what are the strategies which have been adopted. Then we get into AI ops in observability, and then we'll see what are the benefits we could get it, and then a little more details about the contest we are hosting it in so that it is in line with the observability. So going on, so first when I heard about this observability, if monitoring is knowing the known unknowns, observability provides an ability to ponder the unknown unknowns, that too on the fly. So this is the definition which was very intriguing when I just started looking at this. Knowing the known unknowns is the normal monitoring of any system, but observability goes beyond that. So what is that? We will go to where we will learn as we go through this session. So if I ask the simple question of defining what observability is, it's the way to understand a complex system in very detail. So as per the control theory, observability is defined as a measure on how well an internal states of a system can be inferred from the knowledge of its external output. This is the classical definition of what observability is there. So we move on to find out like why the need for observability has come in the industry. So for that, we need to understand the traditional operations in the industry. So every business is or the organization is moving towards the cloud. So as and when they go to the cloud, they encounter a lot of complexities, difficulties. So this is categorized into three categories. One is the business angle of it, the other is the technology part, and the third one is the people and the process. So these are some of the problems which are traditionally there as you adopt to a cloud methodology or a cloud technology. So going into the technology part, the cloud adoption and SaaSification and adding the microservices adds to the lot of complexity. It is a paradigm shift from the earlier monolithic architecture what we were used to in all the applications what we have developed in the past. So but in with regards to that, microservices are much slightly more complex than the monolithic architectures which we have are aware of. The second complexity comes is since the systems are so complex, it's hard to get that engineering mindset to get a full view of what the system looks like. And the third complexity is to debug. If there is an issue, we don't know where exactly it is, whether it is at the intersection of an application, database, platform, or at the infra level. So those are the complexities, while technology complexities, I would say. And the fourth one is the multi-tiered applications, where there is a need for monitoring the reliability across the gateway, API integration, and messaging hub. These are the technological difficulties in adopting to the what are the challenges you will face across when you move to the cloud application. As far as the business is concerned, uh, they sometimes set a very unrealistic system level agreements on SLIs and SLOs as they defined in as a site reliability engineering, which possibly will lower the velocity of the release for the new any new updates you want to do with the velocity of which gets reduced. And the effective in managing the incidents are also going to be a much challenge. So, and we need to have a right kind of balance between the way we release the new features as well as vis-a-vis on the reliability of your applications. So these are some of the complexities or the difficulties you go through in an industry as far the business is concerned. As far as the process and the people are concerned, the manual triaging, it leads to a lot of alert fatigue. There are unnecessary false positives which come in, and then people sometimes ignore the genuine problem. And some of this repetitive task leads to a toil. And these are some things which are people driven or a process driven. Unless we have a place where we could use some of this automation tools to automate the thing so that we could be better off. And in the market currently, if you look at it, there are a lot of tools and techniques scattered across uh, in the marketplace where one does not get an unified view of how to do things. So these are some of these industry related problems when you try to move any of your business applications to a cloud infrastructure. And this is the premises at which this observability has taken the way. And to look at it, they have come up with a lot of strategic initiatives. So by 2022, if you look at it, 80% of the organization would have got adopted to cloud services, and that is where the future is going to be. But without the performance focused approach, most of the services quality will be very low. So that is something which they have predicted, because if you blindly go towards the cloud adoption without paying much attention to the performance, your service qualities will definitely will go down. And as you go forward in 2023, by 2023, 40% of the product platforms will adopt AI ops, and that is something which will be there in the system, because the AI technology is also evolving, and now they have gone to a greater extent and they have got developed a many more powerful algorithms to deal with the real world challenges. So that way there will be an most adoption of AI ops in all your DevOps platform, thus reducing your downtime by at least 20%. And that's what is the projection shows. And by 2024, 75% of the organization monitoring this infrastructure as a service or platform as a service environment will consume the metrics via the cloud providers API. It's going to be fully dependent on the APIs of the cloud providers. And by 2025, 70% of the cloud native application monitoring will use open source instrumentation rather than a vendor specific agents for improved interoperability. So essentially what it is telling is there is going to be a lot of AI ops which are going to be adopted in this cloud DevOps environment, as well as a lot of scope for this open source instrumentation to be there in the marketplace as a consolidation. These are some of these things which are foreseen, and that's the need. That's the area, or that's the skill one needs to adopt so that we become better at adopting the technology, and we know the nuances of how this technology is going to head. So this is something which I thought I would share with you. Probably if you have any questions, just drop down in your Q&A sessions, and we have Q&A sessions at the end. So I could take it up and answer a few of the questions if you wish to. Yeah. So talking about this observability, like it's not a single application where we observe and then find out errors and then fix the problems. It's not that it's applicable in silos. So it is there to look at it end to end, starting from the front end UI till the infrastructures, the complete layer or the landscapes across these platforms. You need to observe it, observe each and every instances, traces, or metrics, or whatever data you collect. So wherever the errors are there, you need to find out that, so that you could fix it. And this observability full stack is all about ability to debug, troubleshoot, optimize the performance across the entire stack, from the UI till the uh, infra level. So all the layers in the complete spectrum or in the complete landscape, you need to have this observability, so that any error occurs, you should be able to fix it, and then so that your downtime of this application is very less, and your performance can be enhanced. And you bringing in this AI ops into the observability platform, you have to do some meaningful analytics, so that you could connect the context, that is the business context, with all the observations you are making. So essentially, it is all, you collect a lot of metrics data, or a log data, traces, or your log files. So you extract the data, you pull out all the useful information and connect it with the business context. And that is where it is rendering very powerful, so that even business leaders are able to appreciate where exactly it is going wrong. So those are the AI ops have come into observability, and then significantly enhance the capability to detect any error and fix it, so that the downtime can be far lesser than the currently which is available in the market. And the third one is coming into this site reliability engineering. It is bridging the gap between the site reliability engineering and the DevOps teams, where the observability plays one of the major role by taking in the error data and fixing it, so that so that your error budget can be reduced, and you can have a very low downtime, and your applications is more reliable in the cloud market. So moving on, what are the things which are responsible for as a constituents, principal constituents for full stack observability? It is first, if you have to look at it, it is the single source of truth. So what I mean by that is, you need to collect all the data. You need to collect, there is something called as metrics, MELT, they call it as, they have briefly termed it as MELT, that is metrics, events, log files, the traces. So these are the four parameters. Let me try to explain what individual parameters in this data when you're trying to collect, or when you're trying to ingest all your telemetry data. So let me try to explain that what is metrics. Metrics is just the starting point of any full stack observability, and they are the low overhead to collect it, and very inexpensive. In a normal monitoring systems also, you collect a lot of metrics data for your quick analysis to measure the overall health of the system. And there are many tools in the market like Prometheus, Telegraph, StatD, and Micrometer are some of these tools which helps you measure, take the value and give you the healthiness of your systems. And events are nothing but the discrete detailed record of a significant point of analysis. Like they are slightly lesser than the log files, giving you the higher level of abstractions. So for example, like if log files give you much more details, this gives you an at a very abstract level where the transaction events or the number of calls it has taken for the database, or what was the duration of those calls. Those kind of significant parameters is what events will give. And the logs are for deeper debugging, trying to understand the problem. So typically in any machine related project, in any product, if you look at it, the product is going to generate a lot of log files. And then if you want to run an analytics on that, like you extract all this log parameters, and then you do a feature engineering on that and try to find out like what kind of parameters are responsible for these error outcomes, and then try to correlate those parameters so that you could do predictive analytics on that, or prescriptive analytics on that, or you could also do a self-heal of your complete system. Like in the past, if you have observed that, so this is more or less trying to convert the whole thing into a data science related problem, where you capture all the log files related to your microservices, and then store it in a single place and try to correlate with the business context, and then try, uh, whether you wanted to do a predictive analytics, prescriptive analytics, or do a selfie. So all these things constitutes the full stack observability, and it is customizable. You need to have a custom design for your visualization so that you have a neat dashboard, and you only pick up the data. You don't pick up all the data. You pick up the data for your visualization, which is having a most business context, like which is the parameters. Like if the transaction is something which we're in a banking sector, transaction of money is the primary thing, where any failure in that part, it is not acceptable. So what all, when this transaction happens, what all the traces are, how far they go into the systems across the layers, you collect all the information and then attach it with the business context and display that visually, so that you could become, if there is any issue, you know exactly where exactly to start and which of the microservices to attend to. Yeah. So these are some of these constituents which are responsible for the any full stack observability. And going forward, like what all these enablers. So if you look at on the left hand side, there is a traditional monitoring system, and on the right hand side there is observability. So what are the significant difference between that? Monitoring gives software system which collects the data about their systems and allows them to quickly respond to any error conditions or issues. The observability, on the other hand, does also practice instrumenting those systems with the tools to gather all the actionable data that provides not only an error issue, but more importantly, why that error has occurred. So it is one step ahead of the traditional monitoring systems, and it works on the principle called as something called as distributed tracing, which collects the data request when it goes from one service to another, recording each segment of this journey as a span, and these spans are also gives important details about each segment of the request, and when they are combined, they combine into one trace which is complete, and that trace gives all the information that is required. So even if something fails there, it has an ability to find out where exactly things have gone wrong. And so if you look at this, the logs, logging metrics, tracing, and the events is something which is missing. So under these blocks, there are two other blocks which are put, which gives the complete, which makes this observability stack more complete. That is RUM, that is the real user monitoring. This is nothing but a practice using the data from an application's uh, real life users to monitor and understand how the application performance happens. This is similar to, I mean, if you look at it, both RUM and application monitoring, application performance monitoring, both are similar in certain sense, but they are different from the point that application performance monitoring has an additional responsibility to optimize certain things. So if RUM looks at only the real time how user is using the application and its performance, but APM will help you how you could optimize so that you could reduce some of these latencies and things like that. And the important thing here is in the observability is discover the unknown permutations. So this is something which happens like when you are working on any data science project. If you do a feature engineering part, so you individually those parameters will not actually contribute to an error, but the combination of those parameters could could give you a different outcome that could be closer to that error condition. So a lot of feature engineering part of the data science comes here as a part of this AI ops, which will enhance this thing, enhance this observability of any system. So this is just to give you an idea about what is the traditional monitoring system and how it goes to the observability. And coming back to the what are the trends which are which have enabled this observability. One is that innovate fast. Innovate fast is like software teams face an enormous pressure to rapidly and frequently ship new features, experiences to the market faster than the competition, because if they don't do that, they will be left out of the competition. So they put a lot of energy to for adding new features into the applications. There is cloud as adopting to the cloud as in a way lesser the barriers for any new entrant. So new entrants can easily adopt to this, and then the way the cloud infrastructures are coming up. So everywhere like they need to move faster. So that is the trend which. So if you need to be faster, like you need to get into this getting the products more faster or more features adapted. So innovate fast is one feature which has enabled the trend of it. And ever the customer expectations are too many. They don't tolerate this slow or if it is error prone, they immediately uninstall the apps from their mobile phones. So they are very demanding and their expectations are too high. So that also brings in this observability is one of the reasons for this observability to trend. And this rise of this DevOps and automation. So everywhere they look for any repetitive task which can reduce the toil, they wanted to automate it. And this CI/CD pipelines which are coming in DevOps are a new adoption to that, so that which is bridging. We discussed earlier that it bridges both this SRE and DevOps. So that's the reason. And so these are some of these things, and the technology. Technology is ever evolving. Like now, more and more people are adopting to the latest technology of this microservices in the cloud architecture. So these are some of the strengths which are aiding this observability. On the other hand, there are some challenges also. So the challenges are like, if you look at it, there is a greater complexity. The complexity in a monolithic architecture was straightforward. Even if there is error, they were able to fix it. But when each of these features are distributed across this, their functions are distributed across these microservices, and things become little more complex there. And there is the high risk frequent deployments and the dynamic infrastructure adds to a lot of high risk aspects, like which is more challenging. And there are a lot of skill gaps. Like earlier they had a group of people in the software industry who were experts in database or networking or working with API. Now in this cloud architecture, one needs to know about this networking as well as API, about the data base experts when they are working on the microservices. That is something that's where there is a gap, the skill gap, which the industry is requiring that, and one needs to have an expertise in all the segments so that they could be more effective and efficient in the industry. And there are a lot many tools in this hybrid environment. If you look at it, there are n number of tools which have come up, which are doing almost similar jobs. Some of these things are too confusing, like to get to adapt to different tools, because when you work across different vendors, so some amount of consolidation need to happen with the tools, so that there is better adaptability of this observability features in the industry. Now, having spoken about the observability, we will look at how AI ops is going to add to whatever we have known. Like, so we have all the data which are collected either through the metrics or through the events, logs, and the traces in one centrally located places. So from that data, like we just have to do some feature engineering part and identify the patterns, the anomalies, and the correlations. So when you acquire, aggregate, and analyze, this is the part of the flow which comes from the data science projects. So then once you have certain correlations to the problem you are trying to solve or an insight you wanted to draw, you act on it and you say like, okay, if this was the error, this is something which you have done. So it could, so if this kind of error happens, this is something which we need to do. So you know what error, what actions need to be taken. So you could build a system in such a way such that you could build a self-heal system where you know what actions to take when you have certain error conditions. And then you enhance this ecosystem. I mean, AI ops certainly enhances because of its powerful algorithms which have been developed. So it can take any amount of data, any time series data, and then give a valid input which could solve this errors and reduce the downtime. So that's where it is. And the other thing which the AI ops helps is like the visibility of the system. So we spoke about the distributed tracing. When you pick up all the parameters, when it traverses across the different systems, it collects the data. So any problem or any error conditions, you have high visibility of the system using this AI ops. So this is a picture of the AI ops where we observe, that is the monitoring part is more related to how you correlate each of this data log files with the business transactions or your error conditions with the anomaly detection, and a proactive analysis, like you know in the from the past, like these are the data which are responsible for the error conditions. If those parameters are deteriorating or you find those values deteriorating, so you can do a proactive analysis and do a corrective analysis so that your system can be up and running. And you also have a provision to do root cause analysis. So every log files support these kind of since you are continuously collecting this data, so that any error conditions, you know exactly what parameters were there at that point in time. So much t minus one, you know, if an error has occurred at t minus one, you know exactly, you know, like what were the parameters condition. So those kind of root cause analysis you could do using the observe. And then this engage is more about the business context, where you whatever the data you have analyzed and you drawn inferences from that, what kind of advice you can give, what kind of actions you can take on that. This is to engage with the customer so that your product can become better. And the third aspect is how do you automate certain things. So there are certain repetitive tasks which are there, which which leads to a lot of error at times, and it is also will lead to a lot of toil. So how you could automate certain things based on the situation and the opportunities. So this is how the AI ops will work in the observability to detect this pattern so that your downtime can be reduced. So now finally coming back to what are the benefits of using this full stack observability is first thing is the mean time to resolution. So earlier in the system, like if suppose an error has occurred in the cloud native microsystem architecture adopted application. So it was very difficult to trace at to which team it needs to go. So people have spent hours together to look at the problem and then come to a solution as to where this error has occurred. So that is a loss of revenue if you look at when you kind of applications in the market. Uh, it's a loss of revenue. So how fast you could detect it. Now with observability, you exactly know because of the trace, you know where exactly the problem has occurred and which microservices have failed or which system has failed. So you could clearly go, and it drastically reduces from 20 minutes to or 3-4 hours to just 10 or 20 minutes after the after the error has occurred and the system is up and running. So that is something which is significant, and you understand the system, like you if you have better context connect with all your log data and the business use case, you have a deeper understanding of your system and you'll be able to fix the errors much faster. The other benefit is like if you're fixing time, if your debug time, all those things, when you deploy it or when the releases comes, you keep deploying, you keep giving more features to that. So at that time, even if the bug comes, like you can easily quickly detect it, and you have more time for innovations and doing better feature additions to your product rather than spending a lot of time debugging it. And it helps in detecting and diagnosing issues. And one more important features which is added is there is something called chaos engineering, where you inject the bug into the system to see like how it is performing. So all the developers will have more confidence to do the chaos testing, so that they understand the system pretty well because of the observability features. So they will be able to test the systems and make it more rugged, so that the failure scenarios can be reduced drastically. So moving on, like what is this future of this observability going to be? Like there is going to be a deep integration with CI/CD, because most of the DevOps applications. So we already discussed that it is bridging the gap between the DevOps and the SRE. So there are going to be a deeper integration with the CI/CD pipeline, and increased adoption of AI/ML because of AIOps. You need to have a powerful algorithms to have a connect of your error cases, or trying to find a pattern to the business context. So you require more and more powerful AI/ML algorithms to have a better adoption. So this is going to be much more adopted more robustly in this observability system. So increased adoption of AI/ML is going to be present in observability, looking at the complexity of the data. So it is humanly not possible to see the whole scenario of which microservices failed and how, because it keeps changing every day, every hour, every minute. So one loses track of the how a visual map of how the system works. So you require AI/ML or AI ops to do that job. And then there is going to be unification of all the tools, so that your observability tools and the business analytics tools unification happens, so that all your business contexts are well established, and there is no even if something happens, you have a backup system to check where to understand the system better. So that is where this business analytics and observability tool unification. So this is where the future of observability going to be there. Coming to the next segment regarding the challenge. So we have challenges. So what we have done is we have categorized this into three segments. So one is easy challenge, so which helps you build on microservices architectures. And the second one is having both microservices, Dockerization, and the cloud adoption, which is the medium one. And the third one is you work on Kubernetes. So when you do this challenge, you will be able to build an end-to-end observability, which is a pluggable solution for any microservices-based cloud native apps. So this is going to be the final challenge of this series. So with that, I think I have taken my 40 minutes of my time, and then I am now open for answering any questions you have.
Thanks, Vijay. Thanks a lot for taking us through all this. We have a question which is related to what you were talking about. This is from Penty. He's a member. The question is, will this be provided as a by design approach for new products and solutions, a one-time transformation for existing solutions, or as a managed service?
So yeah, so let me just repeat or paraphrase the questions if I have understood. So whether this is going to be given as a one-time or as a managed services, am I correct?
Yes.
Yes. So to me, if you look at it, this will not be a one-time solutions, because a lot of parameters and things will change in the cloud native application, that whole environment. So as and when the things change, you need to quickly keep adapting to that, and then you probably have to have a better algorithm to detect some of these error conditions. So it is going to be as a managed services in the cloud. So a lot of people in the cloud provider, cloud service providers is going to come out with this observability tool as an additional tool because of the way the business is approaching the cloud infrastructures. So this is going to be a predominant feature from the cloud service providers, and it is going to be as a managed services. I hope that I answered this question.
I think, yeah, we got your point, what you're trying to say. Penty, do you have a follow-up question around this? No, I think we are good. We are good, Vijay.
Yeah.
So, guys, as Vijay pointed out, we are running this cloud native skill builder competition. We have easy, medium, and hard right now live for a month, and we'll be soon launching an advanced challenge, which will be helping you, as we just said, develop an end-to-end observability pluggable solution for microservices. So, we have the problem statement for that ready. It'll be an advanced challenge to the skill builder competition, and with amazing prizes as well. So if you haven't seen the skill builder competition, I'm gonna share the link in the chat, and you guys can get on the skill builder competition. Hey Zohaib, I will share some links with you on the email. I see your questions on the Q&A. I'll share some links on the email with you, and that will help you get started with AI and ML. And I'll also, share some links which can help you know the future of OpenCV and image recognition, and how will it scale in the future. You'll get an idea of how big it is going to be in the future. Okay, I think that's all, Vijay. I think most of our members see these webinars on YouTube with the recording on YouTube. So we'll be posting the recording on YouTube very soon. And if there are questions in the comments, we'll be reaching out to you. And if you guys have any questions, if you guys read more on it, and if you come up with questions, you can always put down on community Slack, forums, or even the YouTube video comments, and we will get answers from Vijay and Pradeep for you.
So there is one question. Can I ask something related to AI? I see in the chat window.
Yeah, sure. Yeah, I think yeah, he actually asked that question in the Q&A.
Oh, okay, okay.
It was more about how can I get started with AI and ML. So I have a set of links, and
Okay.
I'll reach out to Zohaib and guide him on
All
on
right, all
that.
right.
Yeah.
Thank you so much. Thank you so much.
No worries. Okay. Thanks, guys. So again, if you have any questions, you can reach out to us on Slack or forums, or you can comment on the YouTube video, and we will get answers from Vijay and Pradeep to you guys. Um, and yeah, have a good day. And thanks, Vijay and Pradeep for doing this for us. Thank you so much.
Thank you. Thank you so much.
Thanks,
Thanks
everyone.
so much,
Thanks,
team,
everyone.
for giving this opportunity, and participants for spending time here. I hope this challenging interests you, and then you can learn a lot, earn a lot. Thanks so much.
Yeah. Thanks, guys. I'll just paste the link in the chat for everyone for the skill builder, and then we'll call it a day.
Thank you so much. Yeah. Thanks, Pradeep.
Yeah, thanks, everyone. Thanks, Vijay. Thanks.
Thanks, everyone. Bye.